as a civil or a structural engineer, it is important to design a building professionally. So sometimes when we work professionally, then many times we used to design a building using software, but sometimes it's very time consuming that if we go for software based design for 1 or 2 or 3 story building, which are not critical for design, and as that's randomly or rarely consider earthquake or wind load. So these types of building, we just is to design that building for only gravity load. And actually for 1 and 2 and 3 story, maximum for 1, 2 and 3 story building, I suggest you to design by using manual and Excel sheet. So if you use that procedure, it will give you it will save your time. So in this full series, we are going to design a building. Here is our building floor plan. This is for our ground floor plan, and this is for our first floor plan, a typical floor plan. So this is a 3-story building, a 2-story building. So for the 2-story building, we are going to design by manual and by a manual design procedure with the help of Excel sheet. Okay, and here I have listed some Excel sheet, our ready-made Excel sheet. By using that Excel sheet, we'll design floor slab, floor beam, a staircase, column, single footing, and combined footing. For a 1, 2 and 3 story building, definitely we only need to design that types of elements. Okay, so single footing is enough many times, but sometimes for lower condition or lowering due to lower bearing capacity of our foundation soil, we need to design combined footing. Okay, so let's start. To design a building, you need some elements like first of all, I will give that 2 elements. The one is building moment calculation, and another is design parameters. Okay, so that 2 file I'll provide you for absolutely free. This link I will provide for design parameters. Here is the design parameters link. So in design parameter, you will be able to calculate many things very quickly. Okay, so when you are working as a professional engineer, then we need to design a building very quickly. But when we will go for that simple calculation, it will take huge time. So by using that Excel sheet, it will save you time huge. You'll be able to download that Excel sheet absolutely for free. This link I will provide in that video description. So I'll close it. Now, first of all, what we'll do actually, you have to know about something, that what we go for. Okay, let's go here. First of all, what we'll do actually when we'll go for design, first of all, what you have to do, or you have to understand about load transferring capacity, that which element will be designed first, then which element will be designed. We have to know about it. Let's see. When we are going to design a building, first we have to design a slab. First of all, we have to design a slab. Then slab will transfer its load to beam. If beam is not available for flat slab and flat plate, the building or building load from slab will be transferred to directly column. So then slab will transfer load to beam. Then beam will also transfer load to column. Before that, after slab design, parallelly we have to design a staircase. Why? Because a staircase also transfer load to beam sometimes, and if beam is not connected with a staircase, then it will directly transfer load to column. Okay, it's depend on actually for our architectural arrangement, we have to consider it. Then from column directly our load will be transferred to footing. Clear? So this is the mechanism of our load transferring system, and definitely we have to focus on that element. So first of all, what we'll do, I will design slab and a staircase. This is our first challenge. Okay, so let's go to design slab. To design slab, we need to calculate load on slab, available load on slab. So let's go for it. I'll open our floor plan. Actually, in this course, if I go for every element design, then it will take huge time. I'll cover that course like that way. After completing that course, you will be able to design a complete structure. Okay, so let's start now. Suppose from here we have to design our slab first. Now first of all, we have to see which types of slab available here. All of our slab are connected with beam. Okay, and here we are getting some slab are cantilever. So it's final that we have to design two types of slab. We have to design two types of slab. That is, first for beam connected, and second for cantilever. Okay, then we have to select which slab we'll design actually, because our all slab, we're not able to design all slab also, and also we are not able to provide separate design parameters for different slab. What is the reason and why we are not able to do it? Because if you provide a different slab thickness, reinforcement specific for, let's say, slab 1, and for slab 2, slab 3, slab 4, then it will not be a good practice. Because when our worker will start working, then they will face very difficulties on it. So what we'll do actually, for that types of simple structure, we'll consider a same thickness. And then we'll use same reinforcement spacing. Okay, now for which one we'll go for design actually? Now this is the big question. As we have decided to provide the same thickness and same river, just see, we know the thickness, the more span need more thickness, right? More span needs more thickness, and the more span will give us the more moment, right? And more moments equal to more reinforcement, right? So what we have to do, we have to select a slab. We have to select a slab whose size is bigger than other slab. Clear? If we are able to design the biggest slab of our all slab panel, and if we provide the value of biggest slab to another slab, then another slab will also be satisfied. Clear? So see here, we have one slab, here another, here another, See, this is our slab which are not cantilever. So from them we have to select the biggest slab. So when I have designed the slab, this slab was the biggest. Okay, as I already have pre-designed this building, so that was the biggest. So for that slab, our slab panel was total slab panel from that point to that point and from that point to that point. Actually, unfortunately, I have uninstalled my AutoCAD. I will also provide the AutoCAD floor plan to you. And unfortunately, due to reinstalling my Windows, I have uninstalled my Revit AutoCAD software. So after installing that, I will back to on it. But now I'm giving you the lecture from our PDF, and also I'll provide you the AutoCAD file of that model. Okay, so for that slab panel, what was our total slab panel length and width? I mean shorter direction and longer direction. So here, if we go in that direction, that is 11 plus 7, that means 11 feet 10 inch plus 7. So our total length of our slab was actually 18 feet. Why 18 feet? Because for they have a beam, and our slab panel length will be considered from beam edge to beam edge. Okay, you have to remember it. So that is 18 feet into, in our another direction, that is 12 and 4, that means 16 feet. 18 feet into 16 feet slab panel we have selected. Now we'll go for our next step. So what is the next step? We have to calculate load on it. Clear? 18 into 16 feet. So I will keep its record in Excel. Okay, our value was 18 feet into 16 inch. Clear? Now we'll go for next step. So what is our next step? Our next step is we have to calculate floor finish, live load, partitional load, slab self weight, and total dead load. Clear? Now to do it, for floor finish, actually, what is the basic assumption of floor finish? I have calculated that for 1 inch thick floor finish we need 12.5 psf load, or it will be 12.5 psf. Okay, how I have calculated that? You will take 1 feet by 1 feet, 1 feet by 1 feet, 1 feet into 1 feet area of the slab. Then thickness, I will consider thickness is 1 inch. Then 1 into 1 into 1 divided by 12. 1 inch thickness, 1 divided by 12. So this is the total volume, and I will multiply it with 150. And then maybe we'll get 12.5. Let's check. 12.5. Okay, in this way I have calculated that. Now as a lower, simple structure, I'll consider our slab thickness, or sorry, floor finish will be, let's say 2 inch or 1.5 inch. So 12.5 into 1.5, that means 18.75 psf. Clear? And if you have any question, let me know. I'll answer you as soon as possible. When it's done, then we have to go for live load. So live load we have to consider from our code as per my code, I have considered as a simple structure. So I have considered 30 PSF load as a live load. Then we have to calculate partitional load. Okay, how we'll calculate partition? Okay, before that I will show you how we can calculate self weight of our slab. Self weight. It's very easy. Just self weight of slab in PSF, we can use T divided by 12 into 150. Okay, so if our slab is 5 inch, let's say our slab is 5 inch, 5 into 150 divided by 12. Let's say 5 inch your slab thickness. So total load on per square feet will be 62.5. Clear? So that's why I have considered 62.5 here. Now partitional, we have to calculate now partitional load. Always remember that as we are not using any software, we have to provide any load on our slab as a area load. Okay, and we know partitional load act as a line load, but that line load will convert to area load. How? Let's do it. We are designing that slab, right? As we are designing this slab, so we have to check which portion of partition wall are acting on slab. See, here and here, only that's two wall on our slab, and another wall around it are not on our slab, where our another wall is over the beam. Okay, now from that point to that point, what is the length? Almost 12 feet. And from that point to that point, what is the load? Almost 4 feet. So 12 plus 4 equal to 16 feet. Our total load is, total length of the wall is 16 feet. And inside the room will definitely not provide the wall more than 6 inch. Okay, now I will calculate the wall load by using Excel sheet. Here and load calculation, separate load calculation, partition wall load calculation. So for partitional load calculation, here we have to provide the length of the wall. Already have provided 16 feet. Then we have to provide height of the wall. Now you have to come here in plan. So what will be the height of the plan? Say from that point to that point, our floor height is 10 feet. And here we know we have a slab. Our slab is 5 inch. And if we go with floor finish, it will be almost 6 inch. Okay. Now the remaining clear height will be 10 minus 6 inch. So what will be that? 9.5 feet. Clear? So I'll provide here 9.5 feet. Then thickness of our wall. Already have told you, we'll consider thickness 6 inch. Here's the thickness 6 inch. And area, slab area. We have to provide now our slab area. What is the area of our slab? We have to provide it. So our total slab area, already we have considered, it will be 18 into 16. Actually, here the given slab area 177 square feet. I have calculated with AutoCAD, but unfortunately my AutoCAD is not available right now. From a next lecture, I will show you through AutoCAD. It's showing here 288, here 177. It's almost same. Sorry, total slab area 18 into 16. So our total slab area will be 288. Here I'll provide here 288. 288. Let's say 28. So see our is the total load of our wall, and here's the area load of our wall, that is 3257. Okay, 3257. So if we go to our slide, and here for partitional load 3 to 32.57, as we have some in toilet, we know in toilet we have a extra portion for our in our toilet. Let's say this portion is 3 by 4 feet. Okay, 3 by 4 feet, that extra portion of a toilet, that height will be almost 4 inch. So now we'll calculate that now we'll calculate this volume, and then I will provide that load on our slab. How will calculate that? To calculate it, I can use Excel. First of all, 3 divided by 12, 4 divided by 12, 3 divided by 12, sorry, equal to 3 divided by 12. Okay, use calculator. 3 divided by 12, that means 0.25. I'll provide here value 0.25, and 4 divided by 12, it will be 0.333, and another is what, 4 inch, so also 0.333. okay, it will be 3 feet, it will be 4 feet, and it will be 0.33 its thickness, 4 inch thickness. So now we'll go for total area. So what will be the total area? Total area will be 3 into 4, 12 into 0.33, that means 3. Okay, 3.96, that means 4 actually, 4. The total volume will be 4 square feet. Then for not 4 square feet, 4 feet cube. Then 4 into 0.50, then been 600. And now I'll divide it, that 600, its total load, and now I'll divide it, that load, with total slab area 288. Now we are getting our load is 2.0. it is very little value actually. So our previous value was 32.5, and our let's say 32.5 plus 2, that means 42.5, let's say 35. That's it. So in this way we are able to calculate all of our load. Now we'll go for dead load, total dead load actually. So calculator, 18.5 plus 35 plus 62.5, 116. PSI. Remember that this load is, total load is including self weight of slab. But when we'll use Excel sheet to design our slab, then we will not use the slab self weight, because Excel will automatically consider the slab self weight according to its thickness. Now we are all set to design our slab actually. But before that, for interior panel we are ready. Now we'll go for our exterior panel. We'll go for our exterior panel. Here, if you see here, our exterior panel is 3 feet 8 inch. That means total 3 feet 8 inch. So we can consider 3.75 feet cantilever portion. That is our beam, and from here to here 3.75 feet extended part. Now over it, how much load it's carrying, we have to calculate it now. If we see here, and here, it's we'll get a wall here, and over it we'll get grill. Okay, so here we'll provide 6-inch wall for, let's say, 2 feet. Okay, 2 feet 6-inch wall. So for 2 feet 6-inch wall, first of all we have to calculate now total distance from that point to that point, that is 3 feet 8 inch. That means 3.75 plus for that side also 3.75 plus from this point to this points, let's say 12 feet. 12. So total 19.5. I'll go to Excel sheet. Here I'll provide 19.5. Thickness, height will be, let's say, 2 feet. Thickness 6 inch. And area, what will be the area actually? So area will be, as we have considered, 12 feet total length, and width is 3.75. So 3.75 into 12, area will be 44.68. Let's say 45. So our total load will be 52 PSF for cantilever portion actually, total partitional load. And another load like our live load in cantilever or balcony, we have to consider live load. I'll consider live load 60 PSF. You have to provide as per your code. I'll consider 60 PSF. I'll consider self weight will be same, floor finish will be same as previous. Live load will be 60 PSF. And another load like partitional load already have calculated. 52, or partitional load will be 52. Partitional 52. So from our neck, we have calculated all of our load to design our slab. Now from in our next lecture, we'll go for slab design. So thank you very much.